All right, so now we're moving on to lesson 95, which is variables on each side. So thus far, we've probably only encountered having x's or y's or variables, whatever the letter might be, only on one side of the equation. And now we're moving on to having it on both sides of the equal sign. So the first example that we have is 3x plus 3 is equal to x minus 5. The first step that you want to do is collect like terms, so things that look like each other on each side, okay? So you want all of your variables on one side, and you want all of your whole numbers on the other side. Now, one thing to note about this is that we can't have negative variables, okay? So you want to move things to the side that makes it positive, if possible, okay? And so in this first one, what we're going to do is I need to get this x from this side to this side. So just like we've done with every other solving for x, we move things around. Isolate the variable using inverse operations, okay? So if this is just an x sitting there, it means it's a positive x, right? Because we assume there's a positive sign sitting in front of it. So all we have to do is minus x on each side. Now I highly recommend doing each step by step, just to keep yourself organized. So x minus x is going to cancel out, and then we have 3x minus x is going to leave us with 2x. And I'm going to rewrite the rest of the equation. Okay, so now I'm left with 2x plus 3 equals negative 5. Now I need to further isolate that x by taking away that 3. And remember, we do everything else that we can in the equation before we isolate that variable, okay? Before we do the division that we need to do to get rid of that 2 that's attached, that's a coefficient of x that's attached to the x. So this is a positive 3, so I'm going to subtract 3 on each side. The 3's over here cancel out. And I'm left with 2x equals negative 8. All right, now that all the x's are on one side and all the numbers are on the other side, right, the values on the other side, now I can divide. So I'm going to divide each side by 2. My 2's cancel. And I'm left with x equals negative 8 divided by 2. So I have a negative being divided by a positive. So my answer is going to be negative. And 8 divided by 2 is? That's right, 4. All right, so x is equal to negative 4. Now, if we wanted to be really good, we could say, okay, 3 times negative 4 plus 3 is equal to negative 4 minus 5. So what I just did is I took this x value and I plugged it into our original equation. So 3 times negative 4 is negative 12 plus 3 is equal to, and negative 4 minus 5 equals negative 9. Negative 12 plus a positive 3 is negative 9 is equal to negative 9. Is this equation equal to each other? Is it true? Yeah, so we know we found the right x value. So if you plug the x value or the variable value back into the original equation, you should get a balanced equation, meaning what's on this side is the same as on this side, right? It's balanced or level. So negative 9 and negative 9 are balanced. Next example, we have 4x minus 2 is equal to negative x, okay? So I need to move all the x's on one side and all the numbers on the other. Now this one's going to get a little tricky because remember, we can't have a negative value, a negative variable. So I'm going to add x on each side. These cancel out and it's going to leave nothing on this side for a little while, okay? So 4x plus x, sorry, I had 4 x's, I'm adding one more x, so I have a total of 5 x's. Minus 2 is equal to 0, all right? And then I'm going to move this constant, so I'm going to add 2 on each side, and I get 5x is equal to 2. And then now I have to divide each side by 5. Those cancel, so I get x equals 2/5. And that's the answer, all right? So you just have a few, 2 practice problems to do in this. So just remember, collect all the x's or y's or m's or whatever they use for the variable on one side, and then get all the numbers on the other, and then isolate the variable by doing that division is what you're going to always be doing as the division. So if you have any questions, please let me know. All right, so lesson 96 is very similar to lesson 95, where we have a lot of a lot of numbers in our expression here, and we are going to be collecting like terms and solving for x, okay? So the first thing that you want to do is you want to look on each side of the equal sign to see if there are things you can simplify or gather together, like terms you can gather together before you move anything on each side of the plus and minus, or each side of the equal sign, okay? So on this first one, I have multiple x's that I can gather. So I have 4x, positive 3x, and negative 2x, okay? So I'm going to collect those like terms first. So 4x plus 3x is 7x. 7x minus 2x is 5x. I still have this plus 2, and it's still equal to 12, okay? So now I need to further isolate the x value, the variable. So I'm going to move this 2 to the other side of my equal sign. So I'm going to subtract 2 on each side. Those cancel out, and I'm left with 5x is equal to 10. 12 minus 2 is 10. Now that I have all x's on one side and all numbers on the other, all I have to do is isolate that variable now using the inverse operation. So there's multiplication happening here, so I'm going to do division. I'm going to divide each side by 5. The 5's cancel out, and I'm left with x equals 10 divided by 5 is 2. All right? Now this one, they take us a little bit further, and they're giving us multiple x and constant values on each side of the equal sign. Remember, it's the same format, the same strategy. We're going to combine like terms on each side of the equal sign and then start moving things around to get our x's on one side and our number values on the other side. So my first side, I have 3x minus x minus 4x. So I'm going to move left to right. 3x minus 1x is 2x. 2x minus 4x is negative 2x. And then I'm going to bring my negative 3 value down. And my equal sign. Now over here I have two terms that have x. So 5x minus 2x gives me 3x. I'm going to bring my plus 12 down. Now remember I said we want our x value to be positive. So if I subtract 3x to bring it over here, I'm going to have a negative 5x, which I don't want. So what I'm actually going to do is I'm going to add 2x on each side. Which feels weird because we're used to having x over here, but remember I told you it doesn't matter which side it's on as long as the x is on one side and the value is on the other. So these cancel out. I'm left with negative 3 equals 5x plus 2x, sorry, 3x plus 2x is 5x. And I bring my plus 12. Now I need to get rid of this plus 12 because I want this 5x by itself. So I'm going to subtract 12 on each side. 12's cancel out. I'm left with negative 15 equals 5x. Now I'm going to divide by 5 on each side. My 5's cancel out. I have x is being equal to negative 15 divided by 5. I have a negative divided by a positive. So my answer is going to be negative 15 divided by 5 is 3. So the answer is negative 3. All right, there you guys go. All right, so those are the only two examples they give us for this lesson. Again, you have two practice problems. Remember to collect like terms and then start moving things around, okay? Get that x value by itself. Make sure it's not a negative value because x's cannot be negative, all right?